Hey everyone, thanks for tuning in and watching this walkthrough of quest number 6. Let's get started. We're going to tell whether this ordered pair is a solution to this inequality. Right? And this word solution, whether we're talking about an inequality or an equation, or even a system of equations, it always means that it makes the situation, whatever that situation is, true. Whether it's a true inequality, a true equation, a true system of equations. So all we need to do is see if this is x and this is y, does it make this inequality true or doesn't it? So that's what we're going to look at. We're just going to plug in those values for x and y. If x were 1 and y were negative 9, would this be true? Would this side be greater than 2? We've got 5 minus 27. Is that greater than negative, or is that greater than 2? No, 5 minus 27 is negative 22. And that's not greater than, and it's not equal to 2. So we're going to say no. Is it a solution? No, it's not. Alright, we're going to solve this inequality. So let's see. First, I see some like terms that I can put together. So I'm going to put the 10x and the 4x together and get 6x. We get the plus 3. On the other side, we can do 14 plus 43 is 57. Going to subtract 3 from both sides. We get 6x is less than or equal to 54. We divide by 6. And x is less than or equal to 9. Then we need to graph that. Okay, so I'll put 0 here. That means 1, 2, 3, 4, 5, 6, 7, 8, 9 is right here. Just barely made it. I'm going to put a circle and I'm going to close that circle. I'm going to fill it in because if x is 9, then this is true because it has the equal to part there. And then I will indicate that x can be anything else that's less than 9. When I shade this in, I'm really cheating in showing you all of the points that represent the values that x can be. Okay, so I'm really just drawing a bunch of points, but I'm doing it quickly by just scribbling them all in rather than doing them one at a time. Graph the inequality, all right? So we've got two parts to this. We've got the line part, okay? The line is made of a bunch of points, and all those points, right, each of them has a coordinate. The coordinate is representing an x and a y, and if that x and y are plugged into the inequality, both sides will be equal. Okay, so the line is of all the points that represent x's and y's that make both sides equal. Then we get the blacked out half. I like the term blacked out. It's something that a student said this year that I've started to say instead of shaded in, because I think it really represents what's going on. It's blacked out by a bunch of points, an infinite number of points. Those are the points that make both sides not equal. But since we're working with an inequality, that's okay as long as it's not equal in the way that we want it to be. So let's look at that line first. Okay. Like I said, the line is made of all the points that make both sides equal, right? That make this happen. And in this case, since it does have a little equal to thing, we're going to include that line in our solution, in our graph. Okay, rather than just showing you where the line is, we're going to actually draw the line and include all those points in our graph. So you've got a y-intercept of negative 4, right? We're just graphing a line. We've got the y-intercept. We get the slope of 4/3. We go over 3 and up 4, which happens to put us right on the x-axis. We're going to go ahead and draw a solid line, okay, because we're including all those points. Those are all solutions to this inequality because all of the points on this line, wherever they are, will make both sides equal. Okay, this may be your aha moment. This may be the time that it finally clicks with you. Let me show you what I mean by what I just said about this line. Let me take a point that's on this line. I happen to know that if I go over 3 and up another 4, should have drawn the line through this point. Right? If I were to draw this line better, it would have gone like that. So that point, which is 6, 4, 6, 4, right? I'm taking a point from on the line. I'm telling you the line is made up of a bunch of points that make both sides equal. So if I put that 6 in for x and that 4 in for y, let's see what happens. 4 is greater than or equal to 4/3 times x, which is 6, minus 4. So 4 greater than or equal to, the 3 can divide the 6, right? We're left with a 2. 4 times 2 is 8, minus 4, and look at that. Right? Just like I said, both sides are equal, okay? And that's going to happen every time we pick a point from on the line, we plug it into the inequality, both sides are going to be equal, exactly the same. Now we need to find which side is blacked out. We need to black out the correct side, meaning that it's also a set of infinite points that make both sides not equal, okay? And any point we choose, like this line here, is the only set of points that makes both sides equal. So whether we choose points over here or over here, both sides are going to be not equal. But only 1/2 above or below this line is going to make it not equal in this way, okay? And the other half will make it not equal in the other way, in the less than way. So let's imagine we don't know that since y is greater than that we are going to shade above. Let's just pretend we don't know that, and we'll try the method 1, the first method I ever taught you, and that would be a test point. Like I said, this blacked out half is blacked out by a bunch of points, right? So let's just choose a point at random. I use a kind of a air quotes there. We'll randomly choose this point right here, 0, 0, okay, and see if it works. And if it works, then I must have just happened to have picked a point from the blacked out half, and I'll know that is the half that's supposed to be blacked out by points. And if it doesn't work, I'll know the other half needs to be blacked out by all those points. So here we go, trying out 0, 0. 0 is greater than or equal to 4/3 times 0, because that's what we're choosing to use for our point, right? 0, 0. And minus 4. So is 0 greater than or equal to, this is 0, and all that's left is negative 4. Is 0 greater than or equal to negative 4? It is. It's greater than negative 4. So we happen to have picked a point from the blacked out half. And so we'll just finish up blacking out this half. We'll black out this half. Right? That's good. Even if you were to just go like that, that's plenty fine. Just to show me that you know which half is supposed to be blacked out by points. Obviously I missed a bunch. There's some right there I didn't draw, right? But who has time to shade all of that in? Not a lot of people do. Number 4. Okay, so we're going backwards. Here is an inequality that, or a graph of an inequality that we're going to write the inequality for. This is pretty hard to see, but we can do it, it's no problem. So we've got this line here, right? So that's going to give us our equation, right? Y equals blah, blah, blah. And then this shaded region here, we can use it to figure out whether it's supposed to be a greater than or less than. So what's the equation of this line? So y equals, well, I can see the y-intercept is 2. That's pretty obvious there. I can see that it goes up 1 and over 1 right there. Right? I can even go backwards and see that it goes down 1 and over 1, down 1 to the left 1, and it goes right there on the 2 on the x-axis, the negative 2 on the x-axis. So it's clear that the slope of this line is 1. So we have 1x, or just x, y equals x plus 2. That's the equation of this line. Well, I know that when I'm writing my inequality, that I'm not going to put this little equals to, because it's a dotted line. Dotted line tells me that if I were to pick a point from this line and plug it into the inequality, right, both sides will be equal, but the dotted line tells me that I don't want both sides to be equal. I want one side to be larger than the other, or one side to be less than the other. Okay? So when I go to write my inequality, should it be like this, or should it be like this? Which way should it go? Well, let me jump back to this problem number 3. I never showed you method number 2. Method 2. Okay, I've said it many times. Y is vertical. It's up and down, right? And vertically, vertically, big numbers come from here and small numbers come from here. By here being big, I mean like up. You go up to find big numbers, and you go down to find small numbers. Okay? And y needs to be greater. Y needs to be a big number. It needs to be bigger than anything this side comes up with. So since I need y to be big numbers, I black out the half that's above the line. So I could use method 2 backwards, and I could say, well, I need y's that are small. I need small y's. Okay. Instead, since I need them to be small, right? See how it's blacked out on the bottom half of this plane, right below the line? Then I could say, well, I know that means that y needs to be less than. But maybe you are a method 1 fanatic. You love the test point, okay? So let's go backwards and pretend like I don't know whether it's supposed to be greater than or less than. I'll just choose a test point. We like our test point as 0, 0. We'll plug it in here, and based on what happens, what the result is, we'll know which way the inequality is supposed to point. So we'll plug in 0 for y, 0 for x, right? We don't know what we're supposed to have here yet. Plus 2, okay, 0 and 2. What's the relationship there? Is 0 less than 2 or is it greater than 2? It's clearly less than 2. And so when we go back here, we know to put less than. And so either way, we get the right result. Y is less than x plus 2. I'm going to solve this inequality. First I'll distribute. I got 5g plus 25 is less than or equal to 15. Then I'll subtract 25 from both sides. Then 5g is equal to negative 10. And less than or equal to, not equal to, less than or equal to. And then divide by a positive 5 on both sides, and so we get g is less than or equal to negative 2. Okay, here we go, solve this inequality. Negative 8, we're going to distribute that negative 8, you get negative 8w. Negative 8 times negative 2 is positive 16. Negative 8w plus 24, you may see something funny going on here with a negative 8w and a negative 8w. Okay, at this point, just try to imagine any number that you could plug in for w where, and see if this might be true. Well, I've got some number, right? I mean, really, if you think about it, let me highlight this. That's huge. There we go. Highlight the negative 8w, highlight this negative 8w. I'm highlighting them because they're exactly the same. So this part on this side and this part on the right side, they're identical. Whatever I put in for w, this part is going to be the same. If this comes out to be 5, this is 5. This is negative 3004, this is negative 3004. These are exactly the same thing. So if I take a number, right, and the exact same number over here, I take that number and I add 16, all right, how's that going to compare to the exact same number with 24 added to it? Well, 24 is bigger than 16, and we're going to add 24 to this number, or we're going to add 16 on the left side to the exact same number. So this number is naturally going to be less than this number, always, all the time, no matter what you plug in for w, this side will be greater, this side will be lesser. So this will always be true, because you look at what we have a less than. This side needs to be less than this side, and it will always be that way no matter what w we plug in. So I already know this is all real numbers. Or if you put infinite solutions, that's cool. Yeah, that works just fine because there are infinite solutions. Maybe I didn't catch on to that right now. And I added 8w to both sides. And I got 16 is less than or equal to 24. Well, that's just true. It's true. It'll always be true. It'll never not be true. And there's no w in here. There's no w to solve for. W doesn't have an effect on this relationship. 16 is less than 24. So it's just another way of showing everything that I just talked about. There's nothing that I can plug in for w that will mess this up. This can never be affected by my choice of w, because in this inequality, there is no w. So there's nowhere to even put the w to have it try and do something. Okay, so all real numbers. Now, if this had come out to be just, like alternate reality here, use my thought bubble here to imagine what if this happened. What if 16, this is too light, it's just too light. What if 16 came out to be greater than or equal to 24? Well, that's not true. And it never will be true. There's no way for that to be true, right? We're imagining that this inequality sign was the other way. This will never be true. And so in this case, we would have to say there's no solution. There's no way to come up with a W that would ever work in this inequality, right? So if it comes out to be true, all real numbers. If it comes out not to be true, no solutions. All right. Let's switch to orange. You earn $9.50 an hour at a summer job. Write and solve an inequality that represents the number of hours you need to work in order to buy a digital camera that costs $152. Okay, so this camera costs $152. So we got two things here. We got the cost of the camera, and we have the amount that we're going to earn. Okay, what would we say about the amount that we're going to earn versus the amount that the camera costs? Could the amount that we earn be less than the amount that the camera costs? Not unless they're gonna, you have a coupon or something, I guess. It costs $152. You gotta make more than what the camera costs, or you could make exactly what the camera costs, right? So as long as you are equal to the cost of the camera, or you are greater than the cost of the camera, you're good. Okay. Well, what does it cost? It costs $152. And how do you calculate the amount that you earn? Well, 950 times the number of hours you work. T for time there. So 950 times the number of hours that you work needs to be greater than or equal to 152. So we're going to divide by 950 on both sides, 9.5 on both sides. T needs to be greater than or equal to, there's my calculator. What do we have here? 152 divided by 9.5, 16. So T needs to be at least 16. It needs to be greater than or equal to 16. You need to work 16 hours at the very least, if not more. Okay. So T is greater than or equal to 16. Or you could, it says you need to work, let's see, write and solve an inequality that represents, what are we looking for? The number of hours you need to work. So you could write this, or you could put at least 16 hours, right? That could be your answer. But also you need to write, not just solve, but also write the inequality, which we've done here. All right, next page, number 8. Solve the system of equations using substitution. Okay, so basically in one equation, we're going to plug in a value for either x or y that we know is the same as that x or that y, okay? So let me just be straightforward about it. This equation tells me that x and 5y minus 10 are the same, okay? And since they're the same, it doesn't matter whether I write x here or I write 5y minus 10 because they're exactly the same. So I'll do that. Instead of writing x, I'm going to write 5y minus 10 minus 9y equals negative 2. The rest of the equation is exactly the same. We've just replaced x with something this equation tells us is exactly the same as x. So I'll go ahead and distribute and get 25y minus 50 minus 9y equals negative 2. 25y minus 9y is going to be 16y minus 50 equals negative 2. Then I'm going to add 50 to both sides. 16y equals 48, which if we divide by 16 on both sides, we find y is 3. Now that I know y is 3, I'll just plug y, 3 back in here for y and figure out what x is. X equals 15 minus 10, right? Plug 3 in there, we get 15 minus 10, and x is 5. So our solution is 5, 3. 5 for x, 3 for y. Okay, solve this system of equations using substitution. Well, this one is not set up the way this one was. This one told us what x was equal to, and this one doesn't tell us that. It doesn't tell us x is equal to anything. It doesn't tell us y is equal to anything. So we just need to make one of the equations do exactly that. Now I see this y sitting here. It's positive, so it's going to be easy to get by itself if I just add x to both sides. So I have 4x minus y equals 1. In this new equation, y equals x minus 10. I add x to both sides, it becomes x minus 10. So now y is equal to x minus 10, so now I can plug in x minus 10 for y. So you get 4x minus x minus 10. These parentheses are very important, especially with this minus here. So be sure to put that around the thing that you're substituting. Okay? Then I'll distribute that negative. 4x minus x plus 10 equals 1. We got 3x plus 10 equals 1. 3x equals negative 9 when you subtract 10 on both sides, and x is equal to negative 3 when you divide by 3 on both sides. So x is negative 3. That's half of what we're looking for. Let's plug that back into this equation because y is already by itself. Y equals negative 3 minus 10. Y equals negative 13. Negative 13. So x is negative 3 and y is negative 13. If I plug in negative 3 and negative 13 here, I'll get the correct solution. I'll get a true statement here. If I plug in negative 3 and negative 13, that'll come out to be true as well. Now we just need to, we have to do very little here. We don't need to solve this, this system of equations. We just need to figure out whether this is a solution to this system of equations. How do we do that? We just plug in this for x and this for y and see if it comes out true. So 0 for y, negative 5 for x, plus 5. Negative 5 plus 5 is 0, and so for this equation, it is a solution. This one here, y is 0, 2 times negative 5, plus 10, that's, let's see, 2 times negative 5 is negative 10, plus 10, and 0 equals 0. Check. So yes, it is the solution to this system of equations. Last one, solve the system by graphing. So we just need to draw a real nice graph, kind of maybe get out a straight edge of some kind and draw nice straight lines. So we're going to graph this equation here. We're going to put a y-intercept of negative 2. Alright, be real careful here. It's got a slope of negative 1. So down 1 and to the right 1. I'm going to get my straight line tool. Get a real nice straight line here. There we go. That's actually have a slope of negative 1. Let me try again on this one. Trying again. There we go, that's better. Okay, other line. Let's switch colors. It's got a y-intercept of 5. Slope of 2/5, so I know I'm going to go 1, 2, 3, 4, 5, and up 2. Alright, let's draw our line. Alright, let's try that again. And go the other way. Ooh. I'll try and follow my slope here. Alright, since I've drawn my graphs really nicely, and by following my slope this way, I landed right here, which I'm pretty confident is also a point on this other line. It looks like it's at negative 5, 3. I just need to be sure, so I'm going to plug those in to both of these equations. So in the first equation, I'm going to plug that in and test it out. 3 equals negative 5 minus 2. 3 equals 5 minus 2. Yes, it does. So check. Feeling good about that. 3 for y. 2/5 times negative 5 plus 5. 5 divides the negative 5, we get negative 1. So 2 times negative 1 is negative 2 plus 5. Negative 2 plus 5 is 3. So check there as well. So we did find the solution by graphing the intersection of the two graphs. Good job all. And thank you for watching. If you have any questions, absolutely do not hesitate to ask.